From a 3-ton ingot to this. Snowboards, a hybrid design that owes its precision to age-old techniques and computerized technology. Contact lenses. Cutting-edge science meets diamond-headed lathes in a surprisingly quick process. And bread. From baguettes to bloomers to bagels, the choreographed symphony, which is a modern-day bread factory. But fails. Later, we look at what goes into the humble loaf before it reaches the supermarket shelves. But first, 20 years ago, they were seen as space-age and exotic. Now they are an everyday item. The squeamish among us still couldn't imagine having something so closely located to our eyes. But contact lenses have revolutionized the way people see themselves, quite literally. Contact lenses have been in existence for over a century. At first completely rigid, they have become as flexible as gelatine. These small discs are used to make soft polymer contact lenses in a variety of colours. Of course, the place to start is with a patient's prescription, which has been digitised for the process to begin. The first stage begins with the data processing control of the shaping. The lathe commences by shaping the inner curvature of the lens. Rotating at 6,000 revolutions per minute, it's armed with an industrial diamond. It shapes the inner surface, the part that touches the cornea. The disc must be free from any imperfection and is polished with a superfine abrasive paste. Polishing is an essential step because it guarantees excellent comfort and perfect vision. A technician measures lens thickness with an extremely precise gauge. The outer surface is then shaped, the part which touches the eyelid. The lens is glued to a spinning arm with a special wax, which will be removed later by an ultrasound device. The wax is moulded in just seconds. The outer diameter of the lens is now shaped as the computer-controlled arm effortlessly cuts away the excess polymer and is polished. This polishing, done at high speed, calls for an abrasive paste, some oil and a small polyester cotton-like ball. This apparatus polishes several lenses at a time, a step that takes only 60 seconds. A technician then polishes the rims of the lenses. The polymer is then hydrated to make it flexible. Lenses remain immersed in a balanced pH saline solution for 24 hours. The lens becomes engorged with liquid and expands, reaching the desired proportions. Next, the lens is checked. An optical topographer is used to verify whether the spread of the optical power in the lens is precise enough. At every step, the soft, fragile lenses must be handled with the greatest of care. This unit, called a frontofocometer, is a metering device which verifies the optical precision of the lens. Lenses are now completed and are cleaned, then stored in containers filled with salt solution. The vials are perfectly sealed with a silicone cap and another of aluminium. Then they're placed in a sterilizer at a temperature of 121 degrees centigrade for an hour and a half. Amazingly, the contents will remain sterile for a period of up to 7 years if not opened. Although the production of a lens involves 14 steps, if you exclude the hydration process, it only takes 15 minutes to make one. From these simple coloured discs, a crafted precision piece of technology can transform a person's life instantly. Baguette, ciabatta, pita, white slice bloomer, bagel, wholemeal, rye, pumpernickel. The list is endless. As is the bread's reputation. Even the Egyptians and Greeks were master bakers. But how would they react to the choreographed symphony that is the modern-day bread factory? The art of bread making on a factory scale is a job not to be taken lightly. It takes Heath Robinson-like imagination to make all the conveyors, pulleys and knives to work in tandem. The journey starts with 6,000 kilos of flour being poured through a protective grill. 36 enormous containers store the flour before the ingredients are added. For 3 hours, these kneading troughs ferment the yeast, where the dough will eventually rise. Using a combination of timing and brute force, this huge mixer kneads the dough for 8 minutes. Weighing a whopping 1,000 kilos, the contents are emptied into a large tub. The dough is emptied onto a slide system. A small hole at the bottom of the machine allows the dough to escape. Then 2 mechanically operated arms cut the dough into loaf-sized pieces. One of many conveyor systems then transports the dough onto its next destination. Here, dough pieces are rolled into balls which can be more easily worked. The dough balls are then floured to prevent them from sticking during their transportation and when they're moulded. During transport, the dough can rest, allowing the yeast to act. The dough is then folded and rolled. The machine can handle 3 per second for a total of 11,500 an hour. The dough is rolled out to the exact loaf size and falls into baking molds. Different sized holes on this machine mean hot dog rolls. These little dough balls have to be shaped lengthwise and fermented before moulding. In perfect symmetry, the hot dog rolls are mechanically shaped. Dough pieces must not touch one another, so they're spaced apart by a small mechanical arm. Back at the loaf bakery, the next step is starting. Squatted down at the bottom of the molds, the dough pieces go into the prover, where they rise for an hour at 42 degrees centigrade and at 70% humidity. Then they bake for 20 minutes at 255 degrees. When finally baked, the loaves are a golden colour. Then the conveyors take over again. A vacuum system draws the loaves from their moulds. Then they're placed on another conveyor to cool. A guidance system takes care of carrying the breads to various sections of the bakery. When well cooled, breads go to the slicer, which cuts 65 loaves a minute. They are sliced by 2 centimetre wide and 40 centimetre long steel saw blades. The machines then speed the loaves onto their last stage, packaging, where they are automatically packed at 65 per minute. They're now ready for shipping.